So grade 11s. We're going to start with non-permissible values. And like I said during the week, we've already done this when we did the inequalities. Non-permissible values are the same thing as when we find the asymptotes. That's kind of what an asymptote is. For example, let's go with something like this. 3 over x. Well, that x, because you can't divide by a 0, makes a non-permissible value. So when you state this out, and like I said, we've done this already, the denominator can never equal 0. So the denominator cannot equal 0, no matter what it is. So in order to solve that, lots of times we have to factor and solve, but in this case it's just simple: x cannot equal 0. So there's your non-permissible value. So let's get a little bit nicer one going on here. Something that we actually have to think about. Excuse me. Let's see. Let's do this one for a non-permissible value. And I'm just expecting you to do non-permissible values first, and then we'll simplify. So something like this. 3 over 3x minus 3. So there's your rational polynomial expression. Well, this whole expression, the whole expression cannot exist, or doesn't exist, so to speak, if the denominator equals 0. So we have to set it up as a non-permissible value. So real simple, before you do anything or solve this stuff, you want to say all the non-permissible values of this equation, or if you think back to the inequality stuff that we've already learned, the non-permissible value is we're trying to find the asymptote, or where the graph does not exist. So set it up. 3x minus 3 cannot ever equal 0. It can never equal 0. So we factor and solve this now. So in this case, you get a 3 times an x minus a 1 cannot equal 0. Well, because the 3 here does not have a variable with it, it has no effect on it. Okay? So it really doesn't matter. If it has a variable with it, that's different. We'd said it can equal to 0 as well. But in this case, the only one that matters is this factor of x minus 1. So I'm going to add the 1 over to isolate the x, and I get x cannot equal 1. So for this graph, this would be an asymptote. It's actually called your vertical asymptote, and we'll get to that at a different point, but that's exactly what it is. This graph's going to have a vertical asymptote running up and down, and that's what we use this non-permissible value stuff for. Well, let's get to a even harder one, and then we'll go into simplifying, and then you guys can work on this. Let's see. Just trying to think of a trinomial one. Let's go with x squared plus 4x plus 3 all over x squared plus 2x plus 1. There's a perfectly good example. So you've got a polynomial expression, rational polynomial expression. Where this graph exists, we don't know, but an easy way to find where it isn't is to find the non-permissible values. So the non-permissible values, again, where the denominator cannot equal 0. So x squared plus 2x plus 1 cannot equal 0. So trinomial easy. If we do this, I'll show you just so that there's no question where I got the numbers from. So what multiplies to give you 1 that adds to give you 2, and I hope that you come up with the numbers of a 1 and a 1. So that's how we're coming up with our numbers. So when I factor this, I get x plus 1 times x plus 1 cannot equal 0. Now, we're going to find out later that some of this stuff really kind of straightens itself out. But so far, we can set both these factors can equal to 0, but they're the same. So I'll just do 1. X plus 1 cannot equal 0. So I'll minus the 1 over. So x cannot equal -1 in this case. Real nice. Okay. Let's see. What about if I do a little bit different here? Difference of squares GCF situation. Let's go with a trinomial difficult upstairs. 2x squared minus 5x plus 2 all over a 2x squared minus 50. Okay. So, as far as we know, all we're concerned about are the non-permissible values. So, really, define the non-permissible values again. Here we go. Some steps. Non-permissible value steps. Let's go like this. Okay. Number 1. Set the deno can't equal 0. Set it up. 2. Factor and solve. So you're going to factor and solve each of the factors. Okay? That's all there is to this stuff. So in this case, 2x squared minus 50 cannot equal 0. So I've set the denominator can't equal 0. I GCF out a 2 in this case, and I get x squared minus 25 cannot equal 0. Okay, so we've GCF, but we haven't factored completely. So now 2 times x minus 5, x plus 5 cannot equal 0. Set my factors, can't equal 0, and solve them. Just like so. Add the 5 over here, minus the 5 over on this one, and we get x cannot equal a 5, and x can never equal -5. Okay? So there's your asymptotes in this situation, or non-permissible values. It's just another name for it. Okay? So that's as hard as it gets. Some of them get a little bit more crazy if they've got more than one variable, but you just pick one of the variables and solve for it.